This is our vector day 2. One thing you need to understand is what we mean by the bearing. Navigators measure angles clockwise from north, and this is what we call the bearing. What exactly do we mean by measure angles clockwise from north? Let's say I have a 15-degree angle somewhere here, where this theta is equal to 15. Well, first thing I need to know is that north is here, of course south, this is east, and this is west. If theta is equal to 90, the bearing is an angle that is measured clockwise, meaning this direction, and starting from north. So the bearing in this specific problem is from here to here. And that's what we would call beta. Beta in this specific case, if this is 15, this is the complement of 15. Well, it's not quite a, yeah, it's a complement of 15 because these two add up to be 90. So here I will say beta is equal to 90 minus theta. Unfortunately, on most problems, you will be given the value of beta. So to find theta, you will say theta is equal to 90 minus the bearing. Well, based on this formula, you might end up with negative values. If, let's say, the bearing is something big, such as 200 degrees. So let's go ahead and graph it and give ourselves a bearing of 200. To be 200, this is 0. Since I'm coming from here, the bearing to be 200 is located somewhere here. So this value is now 200 degrees. Now, if this is 200 degrees, in other words, I say beta is 200 degrees. Let's go ahead and find theta. Theta would be equal to 90 minus 200, which is equal to negative 110. Unfortunately, theta cannot be negative. So if theta is negative, all you have to do is add 360 to it. So if I want to add 360 to this, I will end up with theta is equal to negative 110 plus 360, which is actually 250 degrees. So whenever it's negative, make sure that you add 360 to it to make it a positive angle. Let's go ahead and do our first example. It says a ship sails 200 miles along. This 200 miles is telling me a magnitude along a 325 degree bearing. Well, I would call this one a vector A, where I know the magnitude of vector A is equal to 20 degrees. 20 miles actually, because we're talking about magnitudes. So this is a distance of 20 miles. And I also know that beta is equal to 325 degrees. Now, if you keep reading, the second portion says there's another vector B, and I will call this one now B, and the magnitude of B is 7 miles. And this time is giving me a beta of 250 degrees. The first step is to find alpha. So let's go ahead and find alpha for both. Instead of calling it alpha, I will call it, of course, theta. So let's go ahead and find theta. For this portion, for A, I will say theta is equal to, start by 90 minus 385. Because this one will be bigger than, it will be a negative value. At the end, I will add also 360. If this is not negative, that will be the value of theta. But this one being negative, I add 360 to make it positive, and you should end up with theta is equal to 125 degrees. So this is my theta. I will do the same thing for the second one by saying theta here is equal to 90 minus 250. Well, 90 minus 250 will give me a negative value, so I will go ahead and add 360 to it, and I will get the value of theta to be 200. At this point, what I will do is, I will go ahead and use these two values to find A plus the vector A, or the component of vector A and the component of vector B. Starting with A, I will say A is equal to, remember To find the component, it will be, I will write the letters here, and this one I will not. So for A, I will say is magnitude of A times the cosine of angle theta, and the magnitude of A times the sine of theta. So for this vector, if I continue, magnitude of A is 20, so it will be 20 cosine of 385 and 20 sine of 300 and actually not 385 but 125. I didn't read it right. This is my value for theta. So instead of 385, I should have put 125. So go ahead and fix it. That will be 125 on both. Well, that's not my goal. My goal is not to just to find A. So I will not go ahead and put this on the calculator yet. Well, you will do the same thing for B, and you will end up with B, or the vector B, is equal to, instead of 20 as the previous one, it will be 7 times the cosine of 200 and 7 times the sine of 200. Well, my goal is to find the displacement vector. The displacement vector is actually the sum of these two vectors, because this one is giving me one direction, this one is giving me another direction. So my goal is to find A plus B. So I will say A plus B, and we know already how to add two vectors, is equal to the first value here, which is 20 cosine of 125, plus the first value here, which is 7 cosine of 200. And this we have now 20 sine of 125 plus 7 sine of 200. And if you calculate it right, you should end up with, my calculator gave me negative 18.049 and 13.989. That again is A plus B. Well, we got A plus B. That's not what we need. What we actually need is the magnitude of this vector. So let's go ahead and find the magnitude of A plus B. Using my calculator, I will say this magnitude is equal to the square root of the first value square plus the second value square. So this one square plus this one square. So that will be negative 18.049 square plus 13.989 square. Note that I'm taking it right from the values, the component of A plus B. So at this point, I will get an approximate value of, by the way, A plus B is actually my R. So this is equal to R, vector R. Let me write it here. A plus B is equal to vector R. I will make it simple by calling it R. So here, all I have to write is vector R is approximately equal to 22.836 miles. Well, that's an important information, so I will go ahead and box it, or I will highlight it. That's one answer that I need. Now, to find the second answer, which is the angle that is bearing, the first thing I will do is I'll go ahead and graph that. So here's my x coordinates, and here's my y coordinates. And I know that the coordinate of the vector, A plus B is given here. So A is negative 18 point something. So I will mark it somewhere here, knowing that this is negative 18.049. B is somewhere here, and it will give me this vector, where this distance, of course, is equal to 13.989. So at this point, I have this distance. It's a right triangle, and my angle that I'm worried about is this first, theta. So let's go ahead and find theta. I will say the tangent of theta is equal to the opposite, which is 13.989 over negative 18.049. and you end up with theta using the tangent inverse is approximately equal to 37.777, where theta is this angle. That's not what I'm looking for. What I'm looking for is the angle that is the bearing, meaning from here all the way to here. Note that theta is only this portion. So to find the whole bearing, I will add 91 to 3 times and theta. So all I need to add is actually 270. So if I add 270 from this, I will end up with bearing, or beta, is equal to, or approximately equal to, 307.777. Let me make sure I write bearing here. And that again is an important information for me, so I will go ahead and highlight it. All right, for number 2, it says the ship sails 20 knots at a 325-degree bearing and the current is moving at 7 knots along. Well, this looks identical to the previous problem. The only difference is this time we have knots instead of miles. So you will solve it. It will give you the exact same answers. So if I want to find out what you will get here, let me write same as number 1, but different units. So here what I will do is I will find the same speed and direction. I will end up with 22.836 as I did before, and this one, instead of miles, it will be in knots, and it will be the same angle bearing, meaning at 307.777 degrees bearing.